Hi viewers, this is Dr. Gunamani Jana, and in this video today we are going to cover the support vector machine. So why the support vector machine is important, what is the support vector machine? The entire video will have the theory part as well as the implementation part also. Now let us have a look what is the support vector and what is the outline of this presentation. Here we are going for this introduction to support vector machines and the scikit-learn libraries, the different dataset descriptions, and we import the libraries, import the datasets. We go for the exploratory data analysis, then declare the feature vectors and target variables. We split the data into separated training and test data. Then we go for the feature scaling. We run the SVM with the default hyperparameters, run SVM with the linear kernel. We can run also SVM with the polynomial kernel or with the sigmoid kernel. Then we create the confusion matrix. Then we go for the classification matrix and area under curve AUC and ROC, and the k-fold cross validations with the supple split hyperparameter optimizations using the grid search CV, and these all the things. This is the things we are going to cover here. Now let us have this thing. The support vector machines, it can be used for both linear classifications, and here it is mainly used for linear classification purposes. And in addition to performing linear classifications, SVM can also effectively perform nonlinear classification using the kernel trick. It enables us to implicitly map the input into high dimensional feature spaces. That is the main thing of this SVM. Here we are using a concept of hyperplane. It is not a hyperline, it is a hyperplane. You understand? So line is a two-dimensional or one-dimensional line. So plane is a two-dimensional, like that you can check it, right? So hyperplane is a decision boundary which separates between given set of data points having different classes. Suppose the entire data set is divided to class A and class B, so that is the plane which is dividing, we call it the hyperplane, right? The SVM classifier separates data points using this hyperplane with the maximum amount of margin, and this hyperplane is known as the maximum margin and hyperplane, and the linear classifier it defines is known as the maximum margin classifier. So this is the things we remember. Then we go for the support vectors. The support vectors are the sample data points which are closest to the hyperplane. Remember. So I'll show you the diagram, then you will understand all things. And these data points will define the separating line of hyperplane better by calculating the margins, right? Now what is the margin now? Margin is a separation gap between the two lines on the closest data points, and it is calculated as the perpendicular distance from the line to support vector or closest data points in SVM. We try maximize. Okay, let us see this thing from this diagram. You can clearly understand. Suppose the entire is the data set. Here is the target is no and the hollow circles are there, and here the target is equal to, there are two different classes are there. So these two different classes are separated by a plane. So this line we call it the hyperplane. Okay, and what are the data points close to this one? We find this is close, this is close, this is close, this is close. Using these closest data points, we construct parallel lines. Okay, so these lines it form a gap, a separation from this point to this point. You can see this we call it as the margin. It's clear? And the points which are on this margin here, you can see it here, then we call it as the support vector. So this support vector 1 2 3, here it is 1 2 3. So these are the support vectors. Clear? So and also this is the margin, you can see, and this is the separating plane or the hyperplane. So this is about this thing. Then how do we do all things? We use a scikit-learn which provides useful libraries to implement support vector machines algorithm on a dataset, and there are many libraries that can help us to implement the SVM smoothly. We just need to call the libraries with parameters that suit our needs. So in this here in this paper I am dealing with a classification task, and will mention the scikit-learn libraries for SVM classifier. Okay, right? So first there is a linear SVC classifier, and as the name suggests, this classifier uses only linear kernel. In linear SVC method classifier, we don't pass the value of kernel, since it is used only for the linear classification purposes, right? Now this scikit-learn, it provides two other classifiers, that is the SVC and the new SVC, right? So which are used for classification purposes, and these classifiers are mostly similar with some difference in parameters. So the new SVC method, which is similar to the SVC, but uses a parameter to control the number of support vectors. We pass the values of kernel, gamma and C along with other parameters, and by default kernel parameters uses RBF, radial basis function, you will be knowing, and as its value, but we can also pass like polynomial, linear, sigmoid, and callable functions, right? So this is all about the theory part. Now without wasting our time, so let us go to our implementation part. Okay, in this implementation part, we come to the Jupyter notebook. As I told you that all things we are implementing in our Jupyter notebook. Here, as I told you that we will be using number of library functions like import numpy as np, import matplotlib dot pyplot as plt, and import pandas as pd. So these things, either it is installed or you can install also pip install, that with that you can do it. So and we import all things. Then importing the data set, here I am using user underscore data dot csv. This also I have taken from this Kaggle. So this is already there in my folder here, I'll upload it. So then what I do it here, so if you want to see, I can see what is the file name, you check it, user data dot csv. So you check it here, user data abcdjhijk11 opqrst, user data csv. You see already I have taken it here, fine. So now with that pd dot read underscore csv, that I assign to the data underscore set. So now the entire data is stored in the data underscore set. So then I define what is x and y. X is equal to data underscore dot I location. So what are the things I want it, all the things I put it there, because I have to decide what is x and what is y, what is the predictor and what is you are going to predict, right? So these are things x and y is defined. These are all these Python commands you will be getting very much acquainted. Otherwise you can have a general Python training program to do all things. Then what you do, we go for the splitting using this sklearn scikit-learn model. So from sklearn dot model underscore selection, import train test split and x train x test, y train y test, which is equal to train underscore test underscore split x comma y, and here test size is equal to 25%. So testing is 25% and training is 75%. Then the random state is equal to 0. So these are the things we have taken. This is the standard. I know I have to go for the splitting into training and testing. Then the feature scaling, for that from sklearn dot preprocessing import standard scalar, and the standard scalar we assign it to st underscore x. So x underscore train, which is equal to st underscore x dot fit, you transform x train. So this as it is the previously also we are just transforming. Then the classifier you are using svc, from sklearn dot svm import svc support vector classifier, and this svc we are using kernel is equal to linear, random state is equal to 0, that assigned to classifier, and classifier dot fit x train y train, right? So now we make a model using that training, x training and y training, right? So now the output it is coming, you can see it clearly. Then I am going for this prediction y predict, which is equal to classifier dot predict x test. So what is the x test value I am giving, so it is able to predict the y predict also. Okay, then we are going for this confusion matrix, from sklearn dot matrix import confusion matrix, and cm is equal to confusion matrix y test and y predict. So what are the y test and also y predicted, all the things it is there. With this we are going for to create the confusion matrix, and then we are using the matplotlib to plot that one. From matplotlib dot colors import listed color map x set comma y set and x train y train, all things are there. So x1 x2 all the things it is defined it here. Then we are going for this plotting plt, because already we declared what is the matplotlib plt. Okay, plt dot x limit, plt dot y limit, all things it is given there. And here the title we are giving plot title is equal to svm classifier training set, and this is the title. Then x level we are giving age, and y level we are giving the estimate salary. So this what is the data set we have taken, we are going to predict the salary in the prediction y axis with respect to the age in the x axis, right? So then we go to the plot legend. Here legend it will be showing the age or whatever, male female whatever things will be showing. Then plot dot show. Once we go for that one, then you can clearly see this is the thing, you can clearly see when the age is there. Can you see clearly there is a boundary separated here these things are here, and this is there. So you can see all the red colors are here and all the green colors are here this side, but still some of the red and green colors also going this side and that side. So once you go for the training and from that property colors import all things, after that once you go and train and then we go for this running this thing, then you can clearly find. So it is clearly defining and most of the things are there, and these are things the things we can ignore. Okay, very limited things are there, right? So I hope with this we are able to distinguish the two different classes. So one is 0 and one is 1. So 0 is the red, you can get it here, and this is less than something because the estimated salary, say I put some salary, it is less than some 50,000 or like that, whatever things are, it is greater than that one. So now we are able to successfully separate by a hyperplane and hyper the things whatever you clearly see. So this was all about this SVM and its implementation part using the Python. If you like this video, please do share with your friends. Also don't forget to subscribe this channel so that all the new videos can reach to you without any further delay. Thank you for watching this video, and take care of your health. Have a good day. Thank you.